Hello everybody, this is Manshesht Sharma, junior at the Hill School. Today, for my Breakthrough Junior Challenge, I will be talking about a mathematical concept known as proof by induction. Proof by induction is a pretty simple concept to understand, but it gets harder as you master it. Proof by induction is a tool that many mathematicians use to prove concepts. Mathematicians use proof by induction by taking empirical evidence that they know and applying it to a case such that any case in front of the empirical evidence that they know shows to be true. Thus, they can prove that their assumption about the empirical evidence has to be true. Let's begin. Proof by induction always has two main parts: the assumption and then the proof itself. We start by assuming. We assume that our proof will be true. Whatever concept we are trying to prove will be true. Pretty funny way to start off if you think about it, assuming that what you're trying to prove is true. Assuming that what we are trying to prove is some sort of function, we first assume that f of n is true. This is the key, the linchpin, if you will, that holds this whole proof together. If we assume that f of n is true for whatever we are trying to prove, then we can use it to prove that f of n plus 1 is true, and then we can prove anything that we want. The reason is that if we use proof by induction to show that f of n plus 1 is true, then we can show that for any f of n plus 1 will always be true. It's a really powerful tool, and I'll show you a few examples. Let's begin with the classic proof by induction example. Using sigma notation here, I'm denoting that all the values k from 0 till some arbitrary natural number n, when added together, equal n times n plus 1 divided by 2. Now I'll prove that this is correct, but I assure you this is correct. Which is 0 plus 1 plus 2 plus 3, all the way up until plus n minus 1 plus n. I'm asserting that this all equals n times n plus 1 over 2. So we've just completed the first part of our proof by induction, assuming that what we know to be true is true. Now I'll prove that this is true by inserting n plus 1 wherever I see an n in this proof. Because by doing so, I will prove that no matter what number, whatever number n I choose to be, it could be 100, it could be 1,000,000, it could be 10 million. As long as I add in 1 and prove that this is true, whatever number I chose, 100 million, 10 million, that has to hold true. Because if we could prove it for n plus 1 by assuming that it is true for n, then we can prove it for n assuming that it holds true for n minus 1. So let's write this out again. This time I'm going all the way up to n plus 1. Now, this is the formula that I used before, but I'm no longer solving for n. I'm going all the way up until n plus 1. So this has to equal n plus 1 times n plus 1 plus 1 over 2. This is what we expect the formula to equal. We've already assumed that from here to here, for all the sum of all numbers from 0 to n equals n times n plus 1 over 2. So let's put that in there, and then we're adding n plus 1. So let's get our common denominators here. I simply multiplied n plus 1 with 2 over 2. Now I have n times n plus 1 plus 2 times n plus 1 over 2. If I notice that I have common factors here, I can factor by grouping, and this equals n plus 2 times n plus 1 over 2. And if I simplify this a little more to reflect our formula above, we see that this is simply n plus 1 times n plus 1 all over 2. You scroll to the top, it's exactly what you get. Factors are switched, so it's the same thing. Our last example is a little bit trickier. It states that for all n greater than or equal to 1, the formula that you can use to solve for that is, the formula that you can use to solve this sum is n times n plus 1 times n plus 2, all divided by 3. Divide that whole quantity by 3. And for those who are more comfortable with sigma notation, this is the sum of all numbers k times k plus 1, where k ranges from 1 to some value n, equals n times the quantity n plus 1 times the quantity n plus 2. Divide that product by 3. That's what you get. So, once again, let me write this out. 1 times 2 plus 2 times 3 plus 3 times 4, all the way up until n times n plus 1 equals n times n plus 1 times n plus 2. Go ahead and pause the video now and see if you can solve this with proof by induction. Now I'm assuming you've solved this with proof by induction, so I'll begin. We will start by assuming that what I've just written down is true. And we will start proving it by inserting n plus 1 wherever there is an n present in our situation here. And then our last term is n plus 1 this time times n plus 1 plus 1. Okay? And we should get n plus 1 times n plus 2 times n plus 3, and the quantity is divided by 3. Okay, so let's take this proof all the way over here. So, once again, let me write that out. So we already know, or we've already assumed, that this much equals our plus. Now we're adding this. N plus 1 times n plus 2. And similarly, similar to the last formula, we are simply going to get a common denominator. And keep simplifying. Alright, now you may notice already that we have, again, common terms that we can factor out. So this gives us n plus 1 times n plus 2 times n plus 3 divided by 3. This quantity is the same as this quantity right here, which we predicted to be our answer, based on this formula right here. Thus we can safely assume now, there's no longer an assumption as we have proved, that when you go from k to any arbitrary value n, the sum of all terms k times k plus 1 equals n times n plus 1 times n plus 2 divided by 3. So thank you very much for watching my tutorial on proof by induction. I hope you now have a better grasp, if you were already familiar with this, or if you are new to this, a very good fundamental grasp on the concept proof by induction. And I hope you understand the power of this tool, because right now we simply prove very common mathematical formulas, but if we use this in the real world, we are basically saying that if we assume some empirical evidence to be true, then use that assumption to prove that some data, some new data that is maybe one step or one concept further is true, then we know that the empirical evidence we assume to be true is always true, and we can use that and apply it to any situation in life. Thank you very much for watching.